For asphalt mixture are uniformly mixed combination of asphalt, cement, and coarse aggregate, fine aggregates, and other materials depending on the type of asphalt mixture. The different types of asphalt mixture commonly used in pavement construction are hot mixed, hot laid, and cold mixed, cold laid. So, asphalt mixture are the most popular paving material used in United States. When used in the construction of highway pavement, it must resist deformation from imposed traffic loads, be skid resistant even when wet, and not affected easily by weathering forces. The degree to which an asphalt mixture achieves these characteristics mainly is dependent on the design of the mix used in producing the material. Three categories of asphalt mixture will be described next, together with an appropriate mix design procedure. So, the hot laid asphalt mixture, hot laid asphalt mixture is produced by properly blending asphalt cement, coarse aggregate, fine aggregate, and filler dust at temperature ranging from about 175 to 3 to 5 Fahrenheit, depending on the type of asphalt cement used. Aggregation gradation. Aggregates usually are categorized as crushed rock, sand, and filler. The rock materials is predominantly coarse aggregate retained in number 8 sieve. The sand is predominantly fine aggregate passing number 8 sieve, and filler is predominantly mineral dust that passes number 200 sieve. It is customary for gradation and combined aggregate and individual fraction to be specified. So this is the table of mix designs and nominal sizes of aggregates. In sieve size, we have 2 inches, 1.5 inch, 1 inch, 3/4 inch, 1/2 inch, 3/8 inch, and number point 4, 4.75 mm. That's the type sieve sizes, and its grading and total aggregate coarse plus fine plus filler required. Amounts finer than each laboratory sieve square openings weight. So also the illustration of the table of passive sieve designation retained on sieve designation and percent by weight. So asphalt content. Having determined a suitable mix aggregate, the next step is to determine the optimum percentage of asphalt that could be used in asphalt mixture. This percentage should be within the prescribed limits, of course. The gradation of aggregates determined earlier, and the optimum amount of asphalt cement determined to combine to give proportion by different material to be used in producing the hot laid mixture for the project under consideration. This determine the proportion usually are referred to as job mix formula. Two commonly used methods to determine the optimum asphalt content are the Marshall method and HV method. The Marshall method is described here since it is more widely used. Marshall method procedure. The original concept of this method were developed by Bruce Marshall. It is a bituminous engineer with the Mississippi State Highway Department. The original features have been improved by the U.S. Army Corps of Engineers. The test now is standardized and described in detail in ASTM. So, the bulk density of sample usually determination by weighing sample in air and water. It may be necessary to coat sample made from open graded mixtures with paraffin. Before determining the density, the bulk specific gravity or GMB of the sample that is compacted mixture is given as GMB equals WA over the WA minus WW. So where is the WA is weight of sample in air and W subscript W weight of sample in water. So We have stability test. Stability test, in conducting the stability test, the specimen is immersed in a bath of water of temperature of 60 positive negative 1 degrees Celsius, 140 positive negative 1.8 Fahrenheit for a period of 30 to 40 minutes. It is then placed in a Marshall stability testing machine as shown in figure 18 loaded. So mao ni ang stability test man itong gamiton nga equipment or machine. So manatana. So seal coats. Seal coats are usually single application of asphalt material that may or may not contain aggregates. The three types of seal coats commonly used in pavement are fog seals, solar seals, and aggregate seals. So fog seal is the thin application of emulsified asphalt, usually with no aggregate added. Slow setting emulsions such as SS-1, SS-1H, CSS-1, and CSS-1H normally are used for fog seals. The emulsion is sprayed at rate of 0.1 to 0.2 gallons per YD2 after it has been diluted with clean water. Slurry seal is a uniformly mixed combination of slow setting asphalt emulsion, usually SS1, fine aggregate, mineral filler, and water. Mixing can be carried out in conventional plastic mixer or in a wheelbarrow if the quantity required is small. So aggregate seals. Aggregate seals are obtained by spraying asphalt, immediately covering it with aggregates, and then rolling the aggregates into the asphalt. Prime coats. Prime coats are obtained by spraying asphalt binder materials onto non-asphalt based courses. Tack coats. A tack coat is a thin layer of asphalt material sprayed over an old pavement to facilitate the bonding of the old pavement and the new course, which is to be placed on the old pavement. Surface treatment. Asphalt surface treatments are obtained by applying a quantity of asphalt material and suitable aggregates on a properly constructed flexible base course to provide a suitable wearing surface for traffic. Superfave systems. As a part of Strategic Highway Research Program or SHRP, a new system for specifying the asphalt materials in asphalt concrete has been developed. This system is known as Superfave, which is shortened form of Superior Performing Asphalt Pavement. The research leading to development in this new system was initiated because prior to Superfave, it was difficult to relate the resulting obtained from laboratory analysis and existing experience of performance pavement without field of experience. The Superfave mix design manual for new construction and overlays. The objective of this mix design is to obtain mixture, asphalt and aggregates that has following characteristic. First is the sufficient asphalt binder, sufficient voids in the mineral aggregates or VMA and air voids, sufficient workability and satisfactory and characteristic over service life of the Superfave system is unique that it is performance-based engineering. Principle can be used to relate the result obtained from test and analysis to field performance. The system consists the following. First, the selection of materials. Second is the volumetric trial mixture design. Third is the selection of final mixture design. So, the selection of materials. Selection of materials includes the selection of asphalt binder and suitable mineral aggregates. Selection of asphalt binder. The binder selected for a given project is based on the range of temperature through which pavement will be exposed and traffic to be carried during its lifetime. The binders are classified with respect to the range of temperature at which their physical property required must be met. So, materials and pavement. This is the field control, mechanical properties, and volumetric design illustration. So, aggregate selection, then the asphalt selection, then down to volumetric mixture design include moisture stability, Then measure of the performance-based material and have a level, nata 3 levels, the level 2 and level 1 and level 3. Sa level 2, nata estimate pavement performance, performance deformation, fatigue, low temperature cracking. Sa level 3, estimate of pavement performance, permanent deformation, low temperature cracking, fatigue. Then sa level 1 is the final mix for production. Field mixture control test. That's all of my report. Thank you for listening.